The Sahara Desert is the world's largest hot desert today, but it wasn't always like that. In the late Cretaceous, a 3,000 square kilometer seaway covered it. That gave rise to a tropical climate filled with life. Today, we call it the Trans-Saharan Seaway. And the sediment record is filled with fossils. Some of the largest catfish ever found are here, along with snakes as long as a city bus. This phenomenon is called gigantism. Usually observed on islands, it happens when life is isolated from predators and has more abundant food, which leads it to grow larger. But scientists think that this could have happened to the Trans-Saharan Seaway too, as waters receded and left certain areas isolated. This ancient sea is worth studying because it witnessed two mass extinctions. The first is the comet that's thought to have killed the dinosaurs and 75% of all life on Earth. An impact winter occurred after dust from the explosion encircled the Earth and blocked out solar radiation. This halted photosynthesis in some plants and plankton. Still, some Saharan life survived. But that's not it. 10 million years later, an event called the PETM rocked the planet. This was a period of global temperatures 5 to 8 degrees Celsius above average. Scientists still don't know exactly why temperatures rose, but they do find evidence of a massive injection of carbon into the atmosphere over a period of about 20,000 years. Some think a comet impact or volcanic activity in East Greenland might be responsible, but generally, none of those things alone explain how fast the warming occurred. Methane clathrates might provide an answer. They were originally thought to only occur in the outer solar system, but now we know significant deposits of methane are frozen under the Earth's oceans. As air temperature increases, so does water temperature. This can freeze some of the methane, which is a potent greenhouse gas which leads to more warming. Life in the Sahara had a harder time here, but some still survived. Fossils show some crocodiles, turtles, and snakes persevered through the PETM. Naturally, scientists are concerned that we still don't fully understand this period. Here's a quote from an author of the study that analyzed the Saharan Sea. So, we know that life in the Trans-Saharan Seaway had a hard time during the PETM, potentially due to feedback loops like methane clathrates. This is an area that needs more study now, considering it's a less understood mechanism of climate change.